Alrighty, ladies and gentlemen, thank you very much for all your attention today on the Forge preview track. We're at our last session of the day, and we scheduled this one last specifically. It's from a very special presenter, Patrick Streule, who's been the architect on Forge since day one of when we first started spiking it, and has designed and or built a lot of the services that he'll be talking about in this presentation. So take it away, Patrick.
Awesome. Thank you very much, Tim. And yeah, welcome everyone. Herzlich willkommen to the last session of today. Before we start, quick show of hands. How many of you have built a Forge app over the course of this conference in our labs? That's probably like 30–40%. That's awesome. And while doing that, or maybe while watching one of the talks today, you might have wondered how some of these features work internally. How have we built that? And maybe you even have a theory. So for the next 40 minutes, I picked a few areas that I personally find interesting and that I hope you find interesting as well. And want to show you how we did that internally, how it works behind the scenes. But before we dive into the details of how we hide authentication or how we achieve tenant isolation, I'd like to quickly recap why the serverless model allows us to do these things in the first place. So let's consider a Connect app today, say a Confluence macro. You basically implement a web service on a stack of your choice, and that's great because you can pick the infrastructure, language, framework of your liking. But it also has downsides. So you have to implement routing, HTTP. You need to ensure that requests are actually coming from Atlassian and not from anyone else. You implement your business logic, of course, and you quite likely also have some data layer that you implement. All of that around your business logic is not only implementation effort, it comes with additional responsibilities. So you need to define a data storage policy. You need to have backups. You need to try your backups occasionally. You have some egress. You might send that data somewhere else. You probably want to document that for your customers so they know what happens with that data. And we as Atlassian, we can't make many assumptions around latency. So when we call your apps, it can take anywhere from a few milliseconds to a few seconds. So that's also the reason why Connect today doesn't support any kind of synchronous module types, like, for instance, workflow conditions or validators. So when we started Forge, there was a project before Forge that we called the EcoSpike, where we were spiking a lot of these ideas that you see today. And we thought about maybe a PaaS is the right strategy. So we could take your app, just run it internally, like we run our other services that we build within Atlassian, and we can take care of a lot of these aspects that I just mentioned. So we provide the storage, so like for our internal services, we can manage the backups, we can define how often they are exercised, and so on and so forth. You run in our infrastructure, so you have some control over egress. We know where data is going, we know which apps actually connect to the outside. And we control the deployment, so we have more control over the latency of these apps if you run them internally. However, you see kind of all the layers are still the same. There's still a lot of boilerplate going on. And there's a lot of complexity given that there's a wide variety of stacks that we would need to support. And we can reduce that complexity of the stack by taking away some of the flexibility. And what that means is we define the runtime that hosts your business logic. And common bits like routing, authentication, authorization are taken out of the apps and are centralized in a service that we call the invocation service. We will see that throughout the presentation a few times. And that combination of invocation service and this runtime around your business logic is a bit of the secret sauce that we're using to implement some of these features that I'd like to show you. And the reason for that is we're not only passing on the payload that you will receive, for instance, from the front end or from a product trigger onto your function. We can also augment that data that we send to the runtime from other sources. And we don't need to pass all the data straight through to the function. We can hold on to some of the data in our runtime around the function. So when you make API calls, for instance, these request Jira calls that you've seen earlier, we can use that information in those calls and never expose it to the function itself. And so this pattern we're using, for instance, to implement managed auth. And for those of you who maybe haven't had the chance to attend the labs or see some of the other talks, managed auth, or when I mention managed auth here, I mean the way to automatically make automatically authenticated calls to our REST APIs. You can just choose to act as a user or as the app itself, call a path, and we take care of the rest. So this pattern that I showed you not only makes it easier to use, or kind of this, what I just showed you, it doesn't make it easier to use for you as developers, it has other benefits as well. So we can use that to offer better security, because the only place where we store long-lived secrets, like the OAuth client secrets, refresh tokens, similar things, is within Atlassian. These never leave our infrastructure. We can manage them in one place, and we only pass out short-lived authorization tokens, access tokens. And you also don't need to manage secrets or kind of storage of secrets by choosing the appropriate level of encryption. And thirdly, we offer benefits for our end users as well. We've seen in Tim's talk this morning in the keynote that this automatic authentication is also something that we can offer for calls to external services. For instance, we had Dropbox as an example. And that means, given that we handle all kinds of authentication in one central place, we can offer that to our end users in a single place as well, which is your profile page on idatlassian.com. And so how does that work under the hood? It's exactly this pattern that I showed you before. Say you access a Jira issue. Your function will receive some data about the context. So there's the issue key, there's tenant information, there's user information. It doesn't look exactly like that, but conceptually that's quite accurate. And we can augment that with the token information for that particular user that we get from the managed auth service in this particular case. We can pass that on to the runtime, both of it, but we only pass on parts of the information. So the function can use the issue key, can use the cloud ID, can use the account ID, but it doesn't have access to the tokens. We hold on to the tokens on the outside. But when you actually invoke request Jira, that goes through our fetch implementation on the outside, and that's where we can add the tokens, where we can add the missing bits for the cloud ID, and so on and so forth to implement this system. But before we can actually so how do we get to the state where we can actually fetch these tokens for a particular user? In that case, the first request is quite likely failing. So there's a 401 from the Jira REST API. We handle this case. We can return an auth error. That's essentially a specific error that we throw in our runtime to signal back to the invocation service that authentication is still needed for that particular user. And the invocation service is then able to take that single error and transform that into something bigger, which is essentially Forge UI that renders a prompt for the end user to go through that authorization flow and actually grant access to that particular app. So for the app, it's very simple. You just essentially do nothing or return an error, and we can transform that into something we can render in the web or on mobile or elsewhere and prompt the user to actually start that auth flow. What happens when a user actually does that? That's a pretty standard authorization code flow that you know from OAuth 2. But when you look at this diagram, I think the notable thing is not so much how the OAuth flow works, but that the app is absent from it, but the managed auth service takes that role of the app instead. And as part of the Forge deployment step, we actually register every app with that managed auth service. So that service is aware of the apps, of their configurations, scopes, and so on. So from the front end, we can just ask that service, hey, please start the auth flow for that particular app. That service redirects to the full OAuth authorization URL that has all the scopes and parameters it needs. You have to log in as a user. You're presented with the consent screen. You review all of that, choose your site, and from that, you get the typical authorization token. Authorization token can be exchanged to a refresh and access token. So that's all pretty standard. OAuth, you don't need to remember the details here. But once we have a refresh token, from then on, we can issue new access tokens for that particular user as long as we want, or as long as the user has not revoked that previous grant. And so that's how we're able to then implement this happy path from end to end. All right, so I mentioned I showed how this convenience API works, but we haven't talked much yet about how this API is exposed to the function. I've also mentioned the runtime a few times, but how we enforce boundaries or kind of expose that API helper is something that I have not mentioned so far. So let's look a bit more into that. And this is basically what we, or what I generally kind of refer to as different levels of isolation here. What we actually want to solve is two areas of risk. The first one is request isolation or tenant isolation. Here's an example that I quickly want to take you through to describe kind of what we want to solve in this particular case. These are Lisa, Angie, and Ed that you see here. Lisa and Angie work in the same company, and I've written a relatively silly implementation of a function here that stores issue summary information in a global variable accidentally. So it's very explicitly here, but there are other ways you could imagine that information ends up in global variables. So when Lisa actually accesses a Jira issue information is sent to our function. It ends up in this global variable, but nothing bad happens, and she gets the expected result. Now, Angie is accessing a different Jira issue, but in this case, we already have information in this global variable that we surface back. And that's, of course, undesired, not something we want at all. And while Angie and Lisa work in the same company, it might not be that bad, but maybe Lisa is a manager who sees more than Angie, and then we have surfaced information that Angie should never see. What's also worth noting is we're not deploying functions per tenant. So there's only one function that handles all calls from all tenants. So even Ed, who works from a different company, would now see the same content that Angie and Lisa have seen before. And that's very undesirable. And it's not something that is particular to our FaaS implementation or Forge in and by itself. It's something that could happen in any service or any app today. And with Forge, we would like to avoid this entirely. I'm going to show you how we do that. The second area of risk that falls into this category of isolation is how do we ensure that code stays put within a particular isolation level or a particular container? How can it not escape and call more API than it's supposed to call? And this leads essentially to this very broad topic of how do we run third-party code securely. And when you think about it, we're actually doing this every day. We're using a browser. Every one of us is using a browser. Browsers download JavaScript code, execute JavaScript code on our machines, but we trust the implementation of the browser and that JavaScript engine that code is not stealing our files from the hard disk and is sending them somewhere else. And so what we're doing in Forge, we're actually just reusing the same browser technology. So for one, it's a Node.js runtime. You've all seen it's JavaScript that we're executing. This is Node.js, it's basically V8. But there's a technology in V8 that we're using here that is called isolates. And isolates is essentially a construct in V8 that allows to run JavaScript code without sharing any kind of resources between the two. It's the same technology that is backing iframes in the Chrome implementation. And when you look at this diagram, and you've written Connect apps before, maybe you see a pattern here. So it's pretty much the same that we do today on the client side for Connect, because an isolate is a bit like the iframe that we run your code in today for Connect. You make API request calls. That's a bit like the API calls that I've shown you in the runtime. And we have this bridge to the host that is implemented in post message on the client, similar protocol that we have on the server side as well. And we have the actual implementation of these APIs that is sitting on the outside, cannot be changed by the code that's running within the iframe in this case, or within the isolate in the Forge case. And that gives us this isolation context and the ability to expose API securely and only the API that we want. So you could say we didn't even get rid of iframes in Forge, we just moved them to the server. All right, so with that in place, with that isolation level, the isolates between your code and our API code around it, we have certain means, or we have the ability actually to do some application level isolation. And one example here is something that we're planning to implement as a first step is what domains is your app allowed to talk to. And it's something that you would put in the manifest. You say, these are basically the domains or the patterns, URL patterns that my app wants to access. We can present that to the person that installs your app so that people know what's going on. And we can also enforce that at runtime because we control the fetch, as we've seen. So we can match whatever you're trying to access against this list of allowed URLs and then either accept that call and invoke that endpoint or not. Very similarly, another way of application level isolation is to not implement something. So we might never implement file system access in our runtime. So that would simply not be accessible to you. You cannot polyfill that. You cannot get around that unless we would actually make that explicitly possible. Fortunately, isolates happen to solve our other isolation goal as well. So that was the request isolation goal, tenant isolation, user isolation. We can do that by taking your code, putting it in an isolate on every request, and then throwing away the isolate after the request is done. Unfortunately, that's not the fastest operation. Your code needs to be parsed. There's globals that get executed. So it's not uncommon that we spend up to a few hundred milliseconds doing that, which is a bit too slow for what we actually are trying to do or what we actually need in our system. So another feature of isolates is helping us here, and that is the ability to take snapshots, memory snapshots of an isolate. So we can do this first step once. We take your JavaScript code, put it in an isolate, gets parsed, globals get executed, we take a snapshot, and once that's done, on every request, we can create a new isolate, put a snapshot in it, and that is an operation that is more like single-digit milliseconds and not 2 digits, 3 digits milliseconds. And single-digit milliseconds is definitely a price we're willing to pay to essentially get tenant isolation, user isolation, complete request isolation for free. With that in place, even my silly code that I wrote here that stores things in global variables doesn't have any undesired side effects. Every request is like the first one. Doesn't matter whether you accidentally store content in global variables. So that's great. Isolates provide us with a lot of good things. Unfortunately, with all the good things come a few bad things as well. One of them is it's not really a standard environment. So we have this isolate. I mentioned we put your code in it. There's our API helpers that are in it. And there's a standard JavaScript core environment. So we have things like JSON parse, kind of all the other standard JavaScript functions. But what about Node.js, for instance? No, you don't have access to these APIs. Do you have access to a browser environment then, the DOM? No, unfortunately, you don't have either. And so that's a bit of an issue because you still want to use packages from NPM, and these NPM packages expect typically either a Node.js environment or a browser environment, but not nothing. And so what we're trying to do over time is to follow a similar strategy to what other companies are doing that are using isolates. Cloudflare is an example, so a CDN implementation. What they're trying to do is to approximate the service worker API. So if you've already written code that runs in the browser and, for instance, modifies requests, does caching to some extent, you could port that code pretty easily to the CDN implementation of functions itself, because it's the same API. And what we're trying to do is we're trying to approximate the Node.js API over time, at least to the extent that the most common NPM packages are usable in a Forge context. I talked a lot about how a runtime wraps your code, and now let's take a look at what's around our runtime. And that is AWS Lambdas. That's where we execute that runtime and your code. And I'm going to continue a bit on the topic of isolation. Bear with me, I have other topics later on. But let's continue with isolation for a minute and look at what's there beyond our isolation layer that I mentioned. So we have at the very top your code, our isolates, our runtime. But there's other gates that malicious code would need to get through to get more access outside, and they're provided by AWS Lambda. The next layer is essentially a sandbox that AWS provides. And you can think of that roughly as something that is comparable to a container. So they're using very similar technologies that Docker uses to implement isolation. So that's control groups, where how much CPU, how much memory you get is controllable. Namespaces that isolate processes from each other. seccomp to limit the syscalls that your process is able to do. So you can think that roughly as a container-like environment. But around that, there's another layer, an actual virtualization layer that is called Firecracker. And if you're interested in more about the Firecracker technology, there's a great talk from an AWS reInvent last year that I can highly recommend. This virtualization layer is very interesting for us because what it allows AWS to do is to take functions from different customers and run them on the same EC2 bare metal instance. And that's exactly what we want as well. We get code from different customers, and we want to run that code in our AWS account, but we would not be happy with an isolation strategy that would rely on different AWS accounts. And so that's where Firecracker helps us a lot, because if AWS trusts kind of their isolation model enough to run multiple customers on the same box, that directly applies to the use case that we have with Forge. One step up, let's zoom out a bit, is a moment about AWS accounts. Let's talk about AWS accounts. We have our AWS accounts where we run our services. So you will find the invocation service. We have another service that we call the deployment service. We saw the managed auth service. These are standard services, like all the other services that we run within Atlassian. And they're all in AWS accounts that are completely separate from the accounts that we run the functions in. So another complete separation layer. We also have more than one account where we run the functions. So deployments can go to one or the other. We can add more over time. The reason we do that is not only isolation. You can think of that as a benefit as well, and it would reduce the blast radius if something went wrong. But we're doing this mainly to get around any kind of unknown hard limits that we might still encounter. What we're doing is relatively unusual, so it's unusual even for AWS. They haven't seen many cases that are trying to do what we're doing here. So we need to be prepared that we're going to hit some limits that we weren't aware of at the very beginning. And multiple accounts is one way around that. The invocation service is aware of the account a function is deployed in, can select the right one. All of these calls are actually AWS SDK API calls. We're assuming a role that has only the minimal permissions that we actually need to do that. And so given that these accounts are completely separate, not connected with any kind of direct VPC peering or anything else, how do these functions call back to the to the Atlassian services, for instance, to Jira, Confluence? And you have to go, in order to do that, you have to go through the front door in Forge. So API@Atlassian.com, like any other app, is the only way to call our APIs. We have nothing behind the scenes, no shortcuts that we're taking. So it's kind of standard front door auth on the way in. All right, enough of isolation. I'd like to talk a bit more about another aspect, which is latency. Latency is important to us because one of the reasons, or kind of not reasons, maybe one of the drivers, I would say, for Forge was like, we would like to offer a way to be in synchronous paths again. So workflow conditions, merge checks, those are things we would like to make pluggable where functions can participate. And low latency, high reliability is something that we need there. Unfortunately, if you've maybe used Lambdas yourself, and especially Lambdas in VPCs, cold starts can be a bit of a spoiler here. So cold starts of Lambdas in VPCs can take up to 5 to 10 seconds or so. That doesn't happen very frequently, but it can happen when Lambdas are scaled up. So if we go from, for instance, 0 to 1 worker or higher, these cold starts can happen when a new Elastic Network Interface needs to be acquired. So we would always need to factor in these outliers of very slow invocations when we would use Forge on a synchronous invocation path. How did we get around that? We just got lucky, I would say. So AWS is very aware of that issue. We're not the only customer that had this problem. So as we stand here and speak, AWS is actually rolling out a change to change their model, how they associate ENIs with Lambdas. There will be only one network interface for an app, or for a function, for a Lambda function actually, and not multiple, depending, that would scale proportionally with the workers. So we pay that price up front on deployment, but we don't pay it at the time when Lambda scale up or down. And so that is being rolled out over the next few weeks. There was a blog post last week from AWS. Our Forge accounts are among the first ones that get that fix. So we're looking forward to actually supporting that as one of the first Amazon customers. Another thing that we're doing, or actually contemplating doing, is single app deployments. So today, when you have an app with multiple functions, we also deploy actual multiple Lambda functions for each of your Forge functions. But in all the Lambdas, we have the full code already. We're not untangling kind of dependencies in your app and just deploy the parts that are needed. It's all the code in every function. And that increases the risk of cold starts again, because maybe one function is less frequently used than the other one, essentially gets evicted and needs to be started up again when it's invoked. So what we can do here is, given that we already deployed a full code base, we can only create one Lambda that can handle all the functions. The downside here is a bit that we no longer get a lot of control over, for instance, different memory allocations per function, so we have to choose just one, or different timeouts. But the isolates help us here again, because we can control timeouts on an isolate level as well. So we could still kind of enforce different timeouts for different functions, even though they're all deployed as part of one Lambda. That's not implemented yet, but we hope that this will be a way to essentially reduce cold starts even further and the impact of them. All right, so in the last part, I'd like to look a bit ahead and how we could use similar patterns to the ones that I've shown you in other areas. Particularly, can we do for storage what we did for compute with Forge? To illustrate that a bit more, I'd like to highlight a few issues that you're very aware of. So Jira Confluence are deployed across 6 different regions today. Chances are that your customers and your apps are in different regions. So maybe your app is in US East, customers are in Sydney. And so any kind of latency between the 2 data centers is 250 milliseconds at least. But if you have like something like an HTTPS request that needs negotiation of TLS, that's multiple round trips, so that can easily add up to seconds rather than milliseconds. So not good for latency. But latency is only one aspect. Another aspect is compliance. And if you've seen Nuwan's talk yesterday, you know that we're planning to give admins control over where data resides, either in the EU or in the US. But chances are also that your app might be in a different realm compared to your customer. And if we could solve that automatically for you, that would be great. Similarly to data, there's other compliance areas, for instance, data deletion after a customer goes away. GDPR is another regulatory thing. And this is an excerpt from our webpage, and we've actually invested significant resources in different areas to support GDPR, to work on data residency, to support data deletion, SOC 2, and so on and so forth. And what we would like to avoid is to put the same burden on pretty much any app developer in the world. So whatever we can on our side to support that, the better. And it's not only compliance aspects like GDPR, SOC 2, encryption at rest that I haven't even mentioned yet. There's a lot of other concerns that you suddenly have when you manage data. So you need to define a data model, you need to implement an API, and then there's the operations part of it. So you need backups, you might need migrations occasionally, maybe capacity planning depending on the technology that you choose, or even DB upgrades from time to time. So storing data is a pretty big deal. But you might ask, we already have a solution for that. Isn't this solved by entity properties? And yes, that is true to some extent. But if you take a bit of a closer look, you will notice some gaps here as well. For one, we think of Forge as a set of capabilities that works across all of our products, not only Jira and Confluence. And if you think about Trello, Ops Genie status page, at least to my knowledge, that there's no corresponding APIs there that would allow you to essentially associate some data with an alert or an incident. And even within the other products, if you look a bit closer, you find some resources that are not covered. I can't associate some data with a board in Jira. Or the users I can associate data with, but that's not the user, the identity user that is available in all products. It's typically the wrapper in the products that have that. So I can associate data with a user in Jira, wouldn't see that in Confluence. And what we like to do is generalize this model a bit. And if you think about what the containment model, so to speak, of all the resources that we have in Atlassian, you would end up with something like this. So we have the organization at the top. There are sites that are contained in organizations. Within the sites are containers, projects, spaces, repositories. And within them are issues, for instance, or pages. And all of that is user-generated content. And the rules for user-generated content, they're pretty much always the same. So we need to care about data retention. So it means deletion after a certain time if you're no longer a customer, residency, encryption, and so on. The other branch here is orthogonal to that is essentially the users. They can be contained in an organization, don't have to, they can be free-floating, and the rules associated with users are a bit different. So that's typically GDPR, right to be forgotten, privacy settings. So optimally, we would end up in a world where we can take a bit of data from our apps and associate it with any kind of branch in this tree, and we would automatically enforce the corresponding rules for that data. And not all data is necessarily associated with a Jira issue, but any kind of free-floating data, if you will, we could automatically associate with your installation context. So if your app is installed in a particular site, all of that data will be implicitly be associated with that site as well. And so in this model, we're essentially just following a model of every piece of data created by apps follows the parent that it's attached to. That applies to data movement between regions or even between tenants, deletion, or encryption. Now, how would an actual implementation look like? And I'd like to show you something that we did in the spike that preceded Forge. This is very hypothetical, but we actually had something running that I wanted to show you quickly, and also get your feedback, what you think about it if we actually did something like that for real. And the way this worked was you add your data types to your manifest. So we have the manifest that has the functions, has your product triggers, but also has data types. So for instance, this would be an asset management example. I define the type of a laptop laptop has a few properties. There's a model, status, is it assigned, is it not assigned, serial number, and so on and so forth. But it also has an additional property, which is a relation there. So that says, like, this object is associated with its other object type, in this particular case, a user. When you deploy an app that defines that, behind the scenes, we would create a GraphQL API based on these types. So in your app, we could offer a very similar convenience API, like API fetch or API as user request Jira that you've seen earlier, to actually create these objects with type safety, everything you need in our data stores. And this part, the assign to, is essentially where we create that association to a particular parent object, so the user in this particular case, but could be something else. And if there would be no explicit association, it will automatically be assigned with the installation context of your app. And if that installation context goes away, all the data that your app created goes away as well. So with the GraphQL API, we can then support interesting queries at the same time that go beyond of what's possible with entity properties today. You could, for instance, start at the user and then traverse into the laptops assigned to the user, get some details there. Or you create a query, query all laptops where the warranty is expired, and then find the users that they're currently assigned to. So those are things that we actually did support in a Spike system, definitely far from production, a bit like my add-on that Tim showed before. But this is something that we're contemplating and would be interested to get your feedback, especially around kind of data storage scenarios that you have that would be covered, would not be covered, other things that we should consider. So if we go back to the beginning and look at the goals that we wanted to solve, we had the goal of predictable latency that we store by deploying our functions in a FaaS. So that gives us predictable latency. We have control over cold starts to some extent. So we could, after a while, consider adding function invocations to synchronous paths like workflow conditions. We wanted to have a great developer experience and expose convenience APIs. We can do that through the runtime. And we can enforce certain application level rules also through the runtime and through the use of isolates in there. And for data, we have some ideas, nothing in place just yet. But this is essentially the set of tools that allows us to achieve these goals that we set out in the beginning. More than happy to answer questions and get your feedback now and later, still around for a while. And thank you very much for your attention this late in the afternoon.
So any questions? Sure, there's going to be a few.
So you mentioned that we're going to have like single applications instead of different Lambda functions for different parts of the application.
Yep.
So wouldn't that mean high invocation costs? Like, that means we have a lot of invocations coming in to that single application. Doesn't that raise costs? Because Lambdas can get pretty expensive.
It could raise costs. So the scenario that would raise costs is if one function, for instance, needs twice the amount of memory or runtime compared to the other function. And that's essentially the ceiling. We essentially need to run everything with that level of memory. Currently, so far in Forge, I think every function that you've used in the labs, functions that we've written internally and that Tim demoed, they all ran with essentially the minimum memory settings. So we wouldn't expect a massive fluctuation in memory consumption. Might be higher than what it is today. But we wouldn't expect a massive increase in cost, although we definitely want to. So that this is more a theory at the moment that we still want to validate a bit more before we actually commit to that.
Hey, question around code isolation. Did I get it right? Are you going to be whitelisting third-party libraries? Or can I include my library, any library?
So far, you could include any library if we solve that problem that there's no Node.js API, no browser API.
Sorry. Can you repeat it again?
Yeah. So we had no plan so far to only support a whitelisted set of libraries. What we still need to solve is this issue that we don't have a standard Node.js environment or browser environment that makes this library work. But otherwise, I think we would trust the isolation model enough to say you can use any library that you want if it actually works. So native libraries wouldn't work in isolates. That's a general limitation. But otherwise, you would be free to use the libraries that you have within essentially size limits and other limits that we have. But there will be no whitelist.
Okay, so I don't have to choose between underscore or Lodash.
Yes, that is completely up to you.
Okay, thank you.
Also on the topic of isolations, you mentioned the snapshots, but then you also mentioned cold starts.
Yeah.
So basically, the snapshots will only help with the invocation cost when the Lambda function is called regularly, right?
It will. So we essentially pay the cost at the time of cold start still to create that snapshot. That's how it works today. So we essentially make the cold start worse, but we make the regular invocation better to achieve the tenant isolation. Because we essentially create that snapshot in the cold start phase.
Awesome. We've just been granted extra time for questions if anyone has some girly ones. Awesome.
Requirements.
In addition to this persistent object store, do you plan to provide something for caching, for kind of in-memory store between invocations?
Something that has come up. So we have floated a lot of ideas during the spike and after it has come up. It's something we could do. So there's no technical hurdle that would prevent us from doing that. It's more kind of a when do we do what, I would say.
Any other questions? Alrighty. Oh, okay, one more.
One at the back. In the meantime, maybe for caching, just quickly, other interesting things we could do, for instance, given that we have this invocation service in front, is what we discussed is that maybe in your responses from the function, you could give us cache hints so we can cache on the outside. It's not something you have to do yourself, but you tell us what to do and we can do that on the outside. Those are things we discussed as well. Yeah.
I'm personally really happy that you chose JavaScript, Node.js, and TypeScript, as I've seen in the demos. And I see how it all ties together with the isolates. But I'm still really curious. Are you thinking of other language runtimes?
At the beginning of the spike, we actually had the goal to support pretty much anything. We said, like, people should be able to use PowerShell to run their functions. In the meantime, I think with what we get out of isolates, with request isolation, with essentially these egress control rules that are relatively easy to implement for us, with the convenience APIs that we want to expose, I think it becomes harder to support other languages for us with the same model. Something we still would like to do, but I think we would need to invest quite a bit more research to figure out how we would do that for other languages. As a data point, Cloudflare that I mentioned in my slides, they're essentially using WebAssembly to support other languages, but running the output within the isolates themselves. So that might be a strategy for us as well. But we haven't really tried anything in that area.
Alrighty, we might have to call it there. Thank you very much, Patrick, for that in-depth and informative talk.